Welcome everybody to this event where we are going to give you a sneak view of our low power cellular modems. We are extremely excited today. I mean, if you think 3 years ago, our R&D director went to Oslo in Finland. And within a couple of months, we assembled a team of what I call the most smart cellular IoT people in the world. And we thought 3 years is a long time. And I'm sure that my customers also thought it's a long time to wait, but now the waiting time is over. And we are extremely proud of the team that we assembled. I mean, there was guys that have all the experience that we lacked in Nordic Semiconductor. In Nordic Semiconductor, we are leading on low power. It's our DNA. We have a broad market engagement model. It's again our DNA. When we couple this with the huge knowledge we brought from our Finnish team, we've been able to present the product that Thomas and his team is going to do now over the next hour. So I hand it straight over to you, Thomas.
Thank you, sir. I'll do like this and just use the microphone. All right. Today is all about cellular IoT. It's about low power cellular IoT. And of course, we're going to talk about the solution that we have been busy working on the last 3 years. We have some really, really cool stuff to show you. However, before I dive into the specifics of our solution, I will spend a few minutes trying to give you a little bit of context on why we started on this development around 3 years ago. First, so let's take that step back and look at what happened the last 10 years. I think it is pretty fair to say that cellular technology has essentially changed our life. It has revolutionized the phone, and it's become a smartphone. And it's changed our life, for better or for worse, you judge. And obviously the key to that has been advancements in cellular technology. Cellular has enabled us to be connected wherever, whenever, independent of Wi-Fi and modems and Ethernet. It comes packing with blazing speed, so we can get all of our work done on these things. We can watch movies, we can watch live TV on these devices. And finally, it's reliable and secure. So I find it so that typically if Wi-Fi doesn't work, cellular will work. It is very, very secure, much less issues than you have with a short-range, low-power wireless networks. The thing is that cellular also has a unique value proposal for Internet of Things. And by Internet of Things, I mean all of those devices that are not our smartphones, not our tablets. The always connected feature of mobile technology means that we can track a package when it moves around in the city or on the countryside, independent of local area networks. It's always connected in the sense that, for example, if your alarm hangs onto cellular, even if your Wi-Fi goes down, your alarm is still connected to the alarm company. It provides reliability and scalability. And one of the key things with cellular, compared to some of the proprietary alternatives for long-range communication, is that it operates in managed and licensed frequencies that enables the carriers to control and provide quality of service to your devices. This is absolutely critical if you're deploying massive business-critical IoT applications. It has to work, whatever is going on around it. Finally, security. If you have deployments that are business critical, or even if they're not, if it's your deployment, you put your dollar down and install these IoT devices, you want to make sure that that data only comes to you. Cellular, using end-to-end IP security, using SIMs or eSIMs, provide that level of security, the same level of security that you trust when you make bank transactions using your smartphone. So with this incredible value proposal, why is it then that cellular in IoT today is relatively small compared to the other standards like Bluetooth, Thread, Zigbee, Wi-Fi, and other? So if you look at cellular IoT, we're talking around 100 million units per year, which is really low compared to these other standards. We believe there are 3 obstacles that exist today. Number 1 is power consumption. I mean, we're fine with charging our phone every day, but if you're deploying IoT devices, we can't run around charge these things all the time. And they can't be powered all the time either. Some of these things need to work even without power nearby, meaning they have to be battery operated, but we have to bring the power consumption down. On the good side, these devices typically need much less data than we need on our smartphones. The second one is size. Some of these devices are going to be space constrained. We want to tag them onto packages, so we can't have large and bulky implementation. They need to be small. And the last one is that compared to cellular, we're going to need extended coverage, and we're going to need support for significantly larger density of devices than we have today. So rural and deep indoor deployments and massive IoT deployments. So these are things that today are really not addressed in the type of standards that you see on your mobile phone. These are things that has been under development in 2 new cellular standards for the last 3 years, namely LTE-M and NB-IoT. And these standards and the implementations by companies like us and others holds the promise to solve these barriers. But we think that there is actually one more significant issue with these cellular IoT solutions today. And it's perhaps just as significant as these 3 obstacles. And that is that cellular is not easy. And with that, I mean from the perspective of you wanting to develop and deploy an end product, the thing, building in cellular connectivity. And we're saying this coming from a background of short-range, low-power wireless, where we've seen ease of use and availability of short-range wireless solutions ignite a revolution in terms of short-range IoT. So we believe that this is one of the things that really has to be solved. So cellular is not easy. From what we are used to, it is actually pretty hard. It's hard to believe when you're coming from our world that just getting hold of the stuff, trying to prototype cellular connectivity in an application is difficult. So you typically need to pick some modems over here, maybe some chipsets over there, an application processor over here, get everything connected if you can get it without signing tons of NDAs and talking to a lot of people. If you get to that point, then you need to stitch everything together, typically involving weeks of software porting and adaptation to get the link going. And from that point, you need to develop the whole thing and then deploying your products. And then you have things like certifications, you have regional differences between the modules, so you need to manage all of these aspects. This is one of those things that needs to be solved if you're going to see massive deployments of cellular in IoT. And this is what the nRF91 is all about. Solving those 3 technical obstacles and then bringing ease of use, the ease of use we are used to from short range, to cellular. Our mission with nRF91 from day one was about making cellular easy. Lower the barriers of adoption, drive and enable innovation and thus adoption in new markets. It was about creating a cellular solution for everything else, and that means everything else except for your smartphone and for your tablets, everything else that can live with lower throughput, but then needs the absolute excellence in power consumption and size. That thing you see over there, that is the first public picture of the nRF91. So what's inside this thing? First of all, this thing is about making the connectivity side easy. This thing packs a complete cellular modem into a package. And it of course supports both LTE-M and narrowband IoT. It has everything you are used to see in a cellular module inside the package, meaning that we have the full front-end circuitry, we have the transceiver, we have the baseband, all the power management, and it's essentially battery in, SIM card, and then the antenna. With this thing, we're providing all the benefits of a traditional module, including the ease of integration and ease of use, and all of the tele-regulatory standard and carrier certifications on this package. We support global operation with one variant, so you don't have to deal with multiple different modules or solutions in the different regions. But it's more than just the connectivity. nRF91 is a complete cellular IoT system made easy. So we've integrated a processor that developers can use to run their full application on. This is a cutting-edge ARM Cortex M33 core that has embedded flash and RAM and a rich set of system peripherals and interfaces that allows this small package to hook up to sensors or whatever is out there, process it, and then connect it directly to cloud via cellular communication. Everything in a cellular IoT system inside this packet. Compared to having external application processor, having to adopt the software and put everything on the board, you're now getting a lower power solution, you're getting a smaller size solution, and you're getting lower external bill of material. So, one of the things is that security is a big deal for IoT. So we've all seen the news the last couple of months about breaches on our computers, on our smartphones. Imagine if you deploy tens of millions of IoT devices that are critical to your business, and now they're getting compromised. So there is no difference between those advanced devices and these small devices in terms of our requirements for security. So with nRF91, we're taking a system-level approach and a system-level solution to IoT security. Cellular in itself is inherently secure from a cellular network point of view, and also by using the end-to-end IP security. And we've implemented the modem as a secure island. But in addition, we're taking advantage of ARM TrustZone technology to secure also the application processor. That's where your application works. ARM TrustZone for ARM v8 and cryptocell technology is essentially the type of security solution that you have in your mobile phone, but it's adapted to an embedded and low power environment. And I believe today we are the first one to announce products integrating both this latest and greatest ARM processor, but also their TrustZone security solution. Of course, with security, the most important thing is that when there is a breach, we can update the device and fix these things. So with the 91 combining everything in a package, we're able to support secure over-the-air updates of both the modem firmware, but also the application firmware, and everything is securely stored on embedded flash inside this device. The other thing we've done is that we pack all of this technology not into what you think is a traditional cellular modem. We pack it into a tiny system on package using some of the most advanced assembly technology that is available today. And we are extremely proud to announce today that we have partnered up with Qorvo to do this. And this is a strategic partnership for the SiP development and the manufacturing. This system in package has a global RF front end integrated. That's a custom part from Qorvo. It also has shield, an advanced shield structure built into the package based on Qorvo's microshield technology. And this is being delivered in a very ultra-compact form factor device of only 10 by 16 times 1.2 millimeter. Unfortunately, our friend Eric from Qorvo couldn't make it today, but instead he put together a small video with a greet to all of you today. So we're going to have a look at it.
I'm Eric Creviston, President of Mobile Products for Qorvo. We're excited to team with Nordic Semiconductor on the development of a new series of low-power, ultra-compact cellular IoT solutions. Qorvo has decades of experience designing and producing RF solutions in very high volume to satisfy strong market demand for wireless consumer devices. In fact, we ship billions of integrated RF solutions into a diverse set of end markets every year. Our global manufacturing footprint, combined with our expertise in advanced RF design and high-volume multi-chip module packaging, make us an ideal partner for Nordic, as together we help solve the toughest RF challenges. We're impressed with the capability Nordic has developed in the cellular modem and the maturity of their application development environment. As we move toward widespread adoption of low-power cellular technology for a variety of applications, Qorvo and Nordic are well positioned to support the market demand in this space. We're excited about the growth prospects for cellular IoT. We believe it has the capability to revolutionize industries and even create entirely new ones. And we look forward to bringing a new category of low-power, ultra-compact cellular IoT solutions to market through our strategic alliance with Nordic.
Thanks, Eric. Together, Nordic and Qorvo today is basically putting a new industry benchmark down on solution size. So what you see here on the right side is our system in package, and it's just these dotted lines are solutions that have been announced over the last 3 to 4 months. And as you can see, in terms of footprint, ours is up to 3 times as small as some of these other solutions. It's about half the thickness, and that translates to about 5 times smaller volume than some of the other solutions. One of the really, really important things and important applications driving IoT is, we believe, is asset tracking and predictive maintenance. So you have this question, where are my things? And this is not only relevant for things that is moving around like packages, but if you have large installations of various devices, just knowing where they are real time and where they are deployed, instead of relying on sort of reporting on where it's deployed, that could mean that is very valuable information. And of course, in what conditions are my things? Is there anything I should do with my things? Are they off track? Have they been exposed to temperature? Are they ready to be serviced? And if they're ready to be serviced, what is the most likely things I will need to fix with my devices? That's why, in addition to this built-in application processor that can do all of the sensor processing, we're also building in a GPS solution. So we have support for cellular-based positioning inside the cellular modem, and then we combine that with a built-in GPS receiver, and those two together will act as an assisted GPS, where you're getting quick fix from the cellular towers, and then you combine that and you get a high accuracy positioning with the GPS. So not only is the nRF91 really, really small, but we're also, with the GPS, with the application processor, and everything that's inside this thing, we're setting a new benchmark on integration. So at CES, someone showed this cellular tracker solution based on LTE-M that they claim was incredibly small and incredibly low power. And it was basically two things. It was this module about this size, and there was another chip that had GNSS plus a microcontroller and stacked die, and they hooked this together. And you can see the size. All of that functionality in that design, we pack into our nRF91 solution, and it's about 4 times smaller than what this other solution is. The key component inside this system on package is, of course, our own system on chip. This is a custom, very highly integrated system on chip that basically integrates all of the functionality, including the multi-mode modem, transceiver, the processor for the application, all the memory, flash and RAM, the GPS receiver, and power management. This chip has been designed in cooperation between our Finland team that are experts in cellular and our Norway team that are experts in low power designs. And obviously this chip is optimized for power and size, and it's really been built and architected from scratch to take advantage of these 2 new cellular standards, the LTE-M and the NB-IoT. And I think sort of enough talk. We need to see a demo. And we are very, very happy and proud to say that we have partnered up with Telia to enable you to see a demo here in Norway today. So, so that's the final piece we need to connect to cloud. So Peter, take it away. Where's Peter? I'll call Peter. Hey Peter, where are you?
I'm just running some errands.
You're gonna do the demo now?
Now?
Yes?
Okay. I'm on my way.
Okay. Do you have the kit with you?
Yeah.
Is it on?
I'll turn it on.
Perfect. All right. So let's see if we can see what's going on. What you're looking at here is basically our own cloud solution where we've hooked up Peter's kit, and he's on his way over here. And you will see this small dot here. That's Peter moving along to this office, and we are tracking him continuously. The way it is set up is that Peter has his demo kit with him, and it's hooked up to Telia's network. What is
Excuse
it?
me, sorry to interrupt, but we also have a connection from the United States.
Cool. Let's see. Okay, so board 125, Redstone Ranch. That's Chris' kit. This is in Portland, Oregon. This is the guy who's leading the team who's doing our cloud side development. And he's probably sitting at this Starbucks now doing some testing. And in this demo, you're seeing Verizon networks. We're hanging on to the Verizon Wireless Network. So again, this is the demo setup. This tool, NRF Connect for Cloud, will be available for our customers. So they're basically getting end-to-end cellular connectivity out of the box. So we talked about hardware, but ease of use and enabling these things to be used for everything else is not only about hardware. It's obviously also about providing a complete software solution, including the modem firmware for cellular connectivity, SDK for the application, and obviously it's about easy-to-use development tools. You just see the NRF cloud here working. And it's about providing kits that are easily accessible so people can pick up and start to innovate. It's about providing out-of-the-box cloud connectivity with the development kits. And that's essentially what we do with our kits and NRF Connect for Cloud. And it's about the Nordic DNA of support and community. So we have the Nordic tech support, we have our FAEs, and we also have the Nordic Developer Zone where people can discuss. This is a completely different package than what you are used to find in the cellular world. This is the way we package in our short-range type of devices. This is the same solution we are now offering to cellular. So just a few words on the demo setup. I think Peder is getting close. This is the US one. Essentially, Chris has his demo kit hooked up to the Verizon Wireless Network, and it's communicating over LTE-M to the internet, and then to our NRF Connect for Cloud service, where we can see position, and we can send sensor data up. And here comes Peter. And that's pretty good, because it's just in time. So while Peter is taking off his clothes, I'll just do a quick introduction. Peter is the product manager for Cellular IoT. And while he's catching his breath, he's going to give you a little bit of a peek under the hood to see what is inside this small system in package. Take it away, Peter.
Thank you. Hey guys, it's good to be in here. I'm going to show you a few things from the inside of the connectivity solution that you're looking at now. So with Nordic, it's all about connectivity. That's the first thing that needs to be there working. In the low power wide area network solution, coverage is the primary factor. The thing that needs to work for anything to work. To achieve that, we've put in a 23 dBm output power PA. Now this is the highest category output power you can get. We also have a minus 108 dBm sensitivity LTE-M receiver. That's a pretty impressive number. This all is supported in a wide range from 700 megahertz up to 2.2 gigahertz. And the combination of this means that we can get up to 4 times the standard LTE range with the LTE-M solution, and up to 7 times the standard LTE range with the NB-IoT solution. So those are two different physical layers with different characteristics. That's also reflected in the throughput. Now, the throughput requirements are determined by the application. How much data do you need to push through? With LTE-M, you can get up to 360 kilobits per second. And with narrowband IoT, you can get up to 60 kilobits per second. Now, if you don't need the full throughput of any of those for your application, you can simply increase the time between each time you talk to the cell tower and thereby reduce your power consumption. Quality of service is also very important. I'm sure everyone can attest to that for NB-IoT devices and narrowband IoT and LTE-M devices. They need to have some certainty that you can actually connect to them. And switching between LTE-M and narrowband IoT gives you great coverage globally. For devices that are moving around, we also support mobility in LTE-M. This is part of the standard. It means that you can take your device that's moving down the highway, for example, and it can seamlessly move from one base station node to the other without losing the connection. It's an important aspect of the asset tracking application. So for cellular IoT, we've seen numbers thrown around for power consumption. 5 to 10 times the battery life, 10 plus years of battery life. But what does that really mean? It's not a very useful number for someone who wants to make an IoT device. So we want to give you some real numbers today. So these numbers are with the 3.7 volt supply, LTE-M, this is at full 23 dBm output power, so when you're furthest away from the base station, with the battery that's 2700 milliamp hours. And with 15 microamps average current, that gets you a downlink latency connection maintained at 10-minute intervals in the EDRX scheme. For something like that, you get more than 15 years of battery life on that battery. It's a relatively modest battery. If you increase to 0.5 milliamp, you can do tracking information every 20 seconds. It's very similar to what you just saw. And you get more than 6 months of battery life on that. And if you increase to 150 milliamps, you can be downloading new firmware onto the device at the full 360 kilobits per second RRC connected mode. And a 512 kilobyte application image can be updated in less than 30 seconds. That's a very important feature for the security, keeping your device secure throughout the lifetime of the device, being able to update it quickly and without too much cost. So let's drill down and look specifically at some of the features of the system on chip, the Nordic SoC that is at the heart of this solution. I'll present some high-level features first, and then we'll talk specifically about the modem and application architecture. So the SoC has been, first and foremost, designed for low power. We took the LTE-M specification and architected everything from ground up to meet those requirements for a low power end node in the cellular IoT space. So to get there, we use basically the same techniques that we've used on Bluetooth devices. We use integrated memories, and we use extensively the low power and low leakage features of the process that we're using. We also share common power management between the modem and the application. And this is an intelligent power management system. So it means that at any given point in time, only the parts of the device that are needed by the application are turned on. Everything else is turned off. And this is a very easy way to save power for the people who implement the application. And we have some other benefits from our tight integration between modem and application as well. We have a very efficient on-chip data and control transfer between the two. Another benefit of that is that the interface between the application and the modem is deep inside the chip, away from prying eyes. So it's another security aspect. So Thomas already mentioned the security islands. I want to reiterate that this is not only a feature of the modem, this is something that is a feature, sort of a common concept for the whole design. So on the application side, we have multiple secure and non-secure application domains through the Cortex M33 TrustZone. On the modem side, it is in itself a secure island, and within the modem, there are also several secure islands. So we're always trying to minimize the amount of code that has access to the most sensitive parts of the design, so that any secure information can only be accessed by a small amount of the code that's running on the chip. It's an important aspect of security. The modem was designed to standard for LTE-M. It also supports NB-IoT. It's implemented with a hybrid modem implementation. We use a standard controller for the baseband, a low power controller. So it all brings out to the table a very light and low power modem implementation, still maintaining a lot of flexibility. One of the key aspects of low power is being able to start up quickly, go back to sleep quickly, making sure that we don't spend a lot of energy loading things from external memory, for example. So when we have everything in the modem running from internal RAM and flash, that means that the minute It starts up, you give power to it, it starts executing code. And we also get a lot of flexibility from that. We can supply our customers with updates. Any part of our system is upgradable. And there's a very flexible transceiver in the front end. We don't need any external acoustic filters. We can support a very wide range of bands to get worldwide operation. So roaming is extremely simple to achieve, and it works. So edge computing is a nice word, or a nice term. We see this as more important here in the cellular space. So we've evolved a little bit the architecture that we have on the nRF52 series to include the cutting edge M-class M33 to get low power, even low power, and the trusted execution support. Powerful peripherals, they draw from the pool of peripherals in the nRF52 series. So any customer is familiar with that, has applications running with that, can very easily get their code ported over. And you can interface to any sensor or external system. So now when you have that code, and you run it, you get a lot of data into the chip, then you should also do some processing, because it's important to send information and not just data. Because useful information can be extracted from data by processing it, and this should happen on the end node to the largest possible extent. That way you save a lot of energy, not having to send too much data over the link, and you also save network usage. So the software is the area where most of our customers spend probably the most amount of time with our device. And this needs to be really solid. And we follow the same model as we do with BLE. We provide a full application development SDK. In the case of cellular, we see CoAP, MQTT, and HTTP and LWM2M as the most useful protocols. Those are included in the SDK. In addition, we have the drivers that are needed for all the peripherals. So the combination of those two things are all the building blocks you need to implement a secure end-to-end cloud to sensor application. And that's what you saw basically here, and that's the NRF Connect for cloud application. And that works out of the box, and then you can modify it to take data from a different sensor or send data to a different cloud, but all the building blocks are already there, and it's working. So taking a step back, looking at a high level at this system and package from a physical perspective, we've designed it to make it as easy as possible to integrate. So it's a 10 by 16 millimeter LGA with a 0.5 pitch. Should be easy enough to put it down on a 4-layer PCB, a simple one. It exposes 32 GPIOs. Those GPIOs are mappable to any of the peripheral functions. So it's easy to route. And it supports coexistence interface, as we mentioned, in addition to, of course, trace and debug to do the development. And then it all terminates to a single-ended 50 ohm RF input. And we have integrated all the crystals and passives. So everything that's really needed externally is the decoupling capacitance. We connect this to any sort of battery in the 3.7 volt nominal range or any other combination of that. We support 3.1 volts to 5.5 volts as a single supply. So all the power management that's needed on the board is included inside the system on package. And we support this from minus 40 degrees to 85 degrees Celsius. So combining short range Bluetooth with cellular is a very powerful use case. So you can either see it as providing a short range connection for local control and configuration of the device, or you can use the cellular connection as a gateway to the internet from your local short range network. So we see that you can combine with any one of our nRF52 series devices. You will get the automatic coexistence interface, and you get the software drivers and the sample application inside of the SDK. It's really easy to combine, and then you mix and match. If you want the simple peripheral function, you take one of the simpler nRF52 devices as a network processor. If you want a more capable router or central, you can take one of the higher capability nRF52 devices and combine with that. And finally, the development kit. It should look confusingly similar to the Bluetooth low energy development kits that we have in the market today. And it's really made in very much the same way. We use a wideband antenna for worldwide operation. It's got the ARM debugging and tracing on board. It's got the Bluetooth on board. And it supports the Arduino Uno shields. So you can take any compatible shield from the web somewhere and take that one with the sensor, for example, that you need for your proof of concept, combine it, and build proof of concept to show the management or the world that this is a workable solution without having to build any new hardware. So that's it. Thanks.
Thank you, Peter. So this is nRF91. nRF91 is about cellular made easy. It's like lower those barriers of adoption to enable innovation and to enable new markets, and do that on cellular. And we don't think that's been done before. This is cellular, designed and optimized for IoT applications from a size perspective, from a power consumption perspective, and from the perspective of integration. So 91, that's made easy, and for everything else. We can't wait to get this thing in your hands, and we're actually sampling lead customers now. Our lead customer sampling program started in December 2017. We're going to expand that program throughout first half of 2018. And that program includes engineering samples, kits, and software. And of course, when you're part of our lead customer sampling program, you're going to get close and dedicated support from the developers and our support engineers. Mid-2018, we're going to start general sampling. There's going to be a phased regional rollout, obviously, but this basically means that kits, samples are going to be available through standard distribution channels. And of course, our objective is to make it as easy as Bluetooth. You hit order, and the next day, that kit is on your board. And then you download the software, the tools you need, and off you go. You have cellular connectivity in less than an hour. And then you can start to innovate on your application. And 2018, we're going to provide the first production quantities, again, matching the regional rollout with all of the regulatory and carrier certifications applicable to the regions. And this is obviously going to be production-ready hardware and software. So I just got to say, respect and honor to the Nordic team that has worked on this for 3 years. This is a very, very ambitious product that we've done. I think it's very forward-looking in terms of the level of the integration and the way we have designed this product. I would like to especially thank our team in Finland, because they have been bringing in all of that cellular expertise and had an incredible attitude of building something based on what they knew before, but something that's purposely built for something completely different than they've done in the past. And last, but not at least, our friends at Qorvo. You know who you are, and you are the people that made this system in package, that was the final piece to our vision, possible and manufacturable. So keep up the work, keep up the good work, everyone, because we're just getting started with this. And then, of course, Telia. Without you, no demo, no way to work on a live network here in Norway. So we have the pleasure of having a team from Telia here. And Andreas is going to give us a little talk about cellular IoT and LTE-M seen from a carrier perspective.
Thank you. Thank you. First of all, congratulations, Nordic Semiconductor, on a very great and promising product, a great launch, and not at least, I think this is a very well-timed launch. I find what you're doing both ambitious, brave, and I hope that Nordic Semiconductor and Telia can work closely together with this. And if you see at the title of my presentation here, Tailoring for IoT and Innovation, and that's pretty much, I think, what we're doing. We are really trying to set up a foundation that people can work with for innovation. Before this day, Thomas and I had a discussion on the importance and also the challenge of being early. And we shared some common experiences. He said that he sometimes got the question that why are you building a product for which there is no net? And we kind of felt the same thing a couple of times. We were very early with the launch of narrowband IoT. And we are early when it comes to launching LTE-M, one of the first launching both. And we have felt the very same thing. Why are we building a net for which there is no devices? But while IoT might be a buzzword, the demand of these devices and the connectivity for them is absolutely not only a buzz. Telia is currently seeing a totally unprecedented request of these devices, and scarcity has so far been a problem for us as well. So I think that while it's both an important thing to be early, to make sure that you actually have someone driving the agenda of being the enabler, it's also very challenging. The good thing is that it's also extremely fun, because you get to see very many of the novel ideas out there. Some of them great, some of them extremely promising, some of them are solving one of the biggest problems in some of the most capital intensive industries out there. While some might be fun, not that revolutionary. We meet people trying to optimize people's toilet patterns, and it's a kind of fun day to meet one day there, looking on how you can revolutionize the energy and offshore industry, and the next time, yeah, you have someone trying to optimize your toilet patterns. I think that both Telia and Nordic Semiconductor sometimes need to remind themselves that it's in the end, it's not necessarily only about the net. It's not only about the device. It's about what use case it enables out there. And for us, it has been extremely important that it's not one solution fit all, meaning that Telia very early took a very carrier agnostic approach to IoT. Meaning it's when you start to look at this as a portfolio where you really unleash the potential of IoT. What you saw before was a live demo in our LTE-M net. I'm going to come back a little bit more about where we are in the deployment of that. But LTE-M is, it shares some of the characteristics with narrowband IoT, but it has the added value of being able to provide that extra throughput when it's needed. And we absolutely see this as a complement to our narrowband IoT offering. And as I said, novel technology also drives novel business models. And both narrowband and LTE-M, what's unique with them is that they are addressing very many new use cases. The constant strive for faster, more efficient, at a lower cost, exponentially enables new use cases. And I think that one of the key drivers here is that the use cases being enabled now are those in which connectivity can be installed, where the connectivity now or the devices now outlives the product cycle. You don't need to add new extra service cost for adding connectivity. Our ambition on this level is that we during the first half, or the first half of rollout will be in 2018. We will have a complementary net between narrowband IoT and LTE-M that by the end of 2019 we intend to have full coverage on both technologies. That's why it's so important to have this multi-mode supporting devices, meaning that we can reach full nationwide coverage before that using a combination of narrowband IoT and LTE-M. Telia is an enabler. We have a limited offering of finished products. There is a few of them. The most important role we play is the enabler role, meaning that we are working with prepackaged solutions and IoT advisory very much to drive the platform business, the connectivity plus. And I think we need to remember again that in the end it's not about the connectivity. The devices are out there to collect information, meaning that if you should be a preferred connectivity provider, you should also try to be the preferred solution when it comes to gathering, ingesting, processing, and to some extent also analyze and deliver data. And that's why the heart and the core of Telia's IoT plan here, or our venture in this business, is based on what we called XCube, which is our platform for just data ingestion, containing rule engines, trying to standardize data formats, meaning that, for example, a customer trying to work with positioning data from many devices, from many carriers, knows that positioning data comes to them in the same format, regardless of device, regardless of connectivity. This is extremely important, especially when you work cross-device, cross-manufacturer, and cross-carrier. Coming back to the demand of this, my team are meeting literally hundreds of companies each year now. And the power of this network is growing stronger and stronger. And so will also the value, as more and more of this data is being orchestrated and can be used for new purposes, enriched, and even more use cases occurs. So with this presentation and the cooperation with the Nordic Semiconductor, I think we have invited even more and opened up for even more use cases and to be solved out there. So I welcome a partnership with Nordic Semiconductor, and I also invite to new partnerships being based on the enabling functions that we deliver. Thank you.
Thank you, Andreas. Thank you very, very much. This is the end of the sneak peek on nRF91. We're of course going to showcase and demo it in public at Embedded World and at Mobile World Congress, and we will continue to we will also share this information on our website, so if you're curious, want to download it and have a look at all of the things, that will be available. Now we're going to have a short 5-minute break, I think, before we continue to the last session, which is a short brief targeted at analysts and investors. Thank you.